Hi everyone, what we want to learn about today is magma intrusions underneath calderas. And then we want you to use this information to judge conceptual models of what the magma might look like underneath Krafla. To learn about magma, we use field geology, geochemistry, and geophysics. We try to put these all ideas together to imagine what magma chambers look like. In the field, we go out and we try and find areas where magma chambers have been sliced in half or exposed by erosion, and we measure the sizes and shapes of these magma chambers. So sometimes we see dikes that may be a few meters or tens of meters across and tens to hundreds of meters in length, forming big sheets that squeeze up through cracks in the crust. These may form parallel to the rift system in Iceland. Other shaped magma bodies that we have are sills. Sills are horizontal sheets that squeeze in between layers in the rock. As they squeeze in, they crack the rock around them and jack up the rock. So the other type of magma chamber that we see exposed in cliffs are cross-sections of huge blobs of magma, so magma chambers or magma reservoirs. And these are a series of irregular shapes that may be kilometers across, so maybe 1 up to 50 kilometers across. And these may be the shape of a kind of giant M&M, or could be giant cylinders, or even back in the day they used to imagine these things as kind of football shapes. The real answer is we don't know, and the only way to know is to go out in the field and try and measure these things in 3D. Try to create these 3D models of their size and shape in the landscape as we see it in front of us. And one of the ways we do this is we use drones, and from those drones we create three-dimensional views of the landscape that can then be made into a model in 3D. To complement the models from the drones, we use our compasses and we take strikes and dips and find out the contact relationships of those magmas and the country rock around them to try and visualize. So the surface geology at Krafla gives us some idea of what the magma bodies might look like. We have a big caldera there. And in order to form a big caldera, there must have once been a big magma chamber of about the same diameter as the caldera itself. There are also other clues. There are fissures. These fissures indicate there might be dikes at depth. There are rows of explosion craters, again supporting this idea that sheets are intruding through the area where Krafla is. This is related to the tectonics and the extension in the area. Also, if you look at the borehole data, the boreholes show that there are sills that have intruded between old layers of old volcanic lavas, showing that sills are also present at Krafla. So our geochemistry also gives us information about the size and the shapes of these magma bodies. It gives us limitations. We know that the rhyolite at Krafla has been created from altered basaltic crust that was remelted by the hotter basalt beneath it. So we know you need large volumes of basalt in order to melt a small volume of rhyolite. And this rhyolite has to be above the basalt, and this rhyolite then gets mobilized and will migrate up through the crust away from the basalt. At Krafla, it really is a bimodal system. It's mostly basalt, then with little splodges of rhyolite, with very little in between. So andesites and dacites are quite rare in Iceland, and where we do find them, you find lots of evidence of magma mixing. So they seem to be the product of the basalt mixing in with the rhyolite that had formed from partial melting before that. You also learn about magma chambers from geophysics. That's imaging the potential magma beneath our feet. And we'll talk about this later. So we know at Krafla we've had all sorts of shapes and sizes and chemistries of magma, from a giant rhyolitic magma body that fed the caldera-forming eruption, to basaltic dike swarms that intruded along fissures and erupted as lava flows to the north. Then smaller rhyolitic explosion craters like Viti, where liquid rhyolite was erupted. But the big question is, what is there today? When we drill back into Krafla, what are we going to find? Are we going to find big bodies of basalt, giant rhyolitic magma chambers? Or is there just little remnants and squeezes and oozes of rhyolite in certain cracks and sills? This is the question for you.